Today we are going to study Science and Technology Part 1st, Chapter 3, Chemical Reactions and Equations. In earlier standard we had studied that the compounds are formed by chemical combination of elements. We also learned that there is a driving force behind the formation of chemical bonds. We all know that the atoms try to attain the stable electronic configuration either by giving or taking or sharing electrons with each other. Due to this, there is certain charge on the atom and this helps in the formation of chemical bond. So now in this chapter we are going to study how actually chemical reaction takes place. What rules are required for the writing of chemical reaction and how to balance the chemical equation. During 18th and 19th century, some of the scientists carried out various experiments on chemical reactions. They proved that from these experiments that chemical reaction composition of matter changes and the change remains constant. That is, when a chemical reaction takes place, the properties of the matter changes and these properties or whatever the change that has taken place remains permanent. While this is in the case for physical change. In physical change, the change that has taken place is temporary and the physical state of the matter only changes, which can be attained back. Now, let's take a look at the following table and identify physical and chemical change from the phenomena. First, the transformation of ice into water. We all know that when ice melts, it gets converted into water and the water can again freeze back to ice. Thus, it is a physical change. Second, cooking of food. When we cook food, various reactions takes place. Like we burn it, roast it, grill it or do perform any other method. Let's take an example of sandwich. When we make a sandwich, we cut the potatoes, veggies and the bread is grilled. Can we attain that back to its original state? No, because it has undergone various reactions and it is cooked. Thus, cooking of food is a chemical change. Now, I am just going to answer the rest below. If you have any doubt, do ask in the comment section. Ripening of fruit, chemical change. Milk turned into curd, chemical change. Evaporation of water, physical change. Digestion of food in the stomach, chemical change. Size reduction of naphthalene wall exposed to air, chemical change. Staining of shabad or kadappa tile by lemon juice, chemical change. Breaking of glass object on falling from height, physical change. Now, you may have a doubt that when the glass is broken, it cannot be attained to its original state. So how come it is not a chemical change? Well, as the glass is broken, only its shape is changed. That is, its physical state is changed. There is no chemical involved in this process. Thus, it is a physical change. A physical change takes place due to change in parameters such as temperature, pressure. Often, a physical change is reversible, but it may be irreversible as like in the case of breaking of glass. while the composition of matter remains same in the physical change. For example, ice is transformed into water on heating and water is transformed into ice on cooling. On contrary, if the composition of matter changes during a process, then it is chemical change, as in ripening of fruit. When the fruit gets ripened, it won't be any longer sweet and healthy to eat. Thus its property changed. When we call a particular process or phenomena as a chemical change, some chemical reactions takes place. A chemical reaction is a process in which some substances undergo bond breaking and are transferred into new substances by formation of new bonds. For example, when the coal is combusted in air, carbon dioxide gas is formed. This is the chemical reaction, where the carbon from coal and oxygen from air reacts while carbon dioxide is the product. The substances taking part in the chemical reaction are called as reactants. As in before example, carbon and oxygen were reactants, whereas the substances formed from a result of the chemical reaction by forming new bonds are called products, where carbon dioxide is termed as the product from the example before. A chemical reaction is represented by writing a chemical equation. So let's study what is chemical equation. Let us first take a look at chemical reaction. A colorless solution of zinc sulfate, ZnSO4, is formed on addition of zinc dust to blue solution of copper sulfate, CuSO4. The simplest way of representing a chemical reaction in words is called as word equation, as this reaction can be written as aqueous solution of copper sulfate plus zinc dust gives aqueous solution of zinc sulfate plus copper. This word equation can be further written in condensed form by using chemical formulae, as CuSO4 plus Zn gives ZnSO4 plus Cu. This condensed representation of chemical reaction using chemical formulae is called as chemical equation. That is, when we represent a chemical reaction using their formulas, that is chemical formulae of the substance, we obtain the equation in a condensed form, which is easy to understand. This type of representation is called as chemical equation. In this equation, copper sulfate, CuSO4, and zinc, Zn, are reactants, while the colorless zinc sulfate that is obtained as solution and the copper particles Cu are the products. The properties of the product are totally different than the properties of the reactants. This is the magic of chemical reaction. The ionic bond in the reactants CuSO4 breaks and the ionic bond in the product ZnSO4 is formed during the reaction. Now let's study how to write a chemical equation. But before that, take a look at the equation number 2. Now let's see the conventions followed while writing the chemical equation. First, in chemical equation, the reactants are written on the left hand side, while the products are written on the right hand side. The arrow heading towards the product is drawn between them. This arrow indicates the direction of the reaction. As in equation 2, CuSO4 and Zn, the reactants, are written on the left hand side. ZnSO4 and Cu are written on the right hand side. The arrow is placed between them. The head of the arrow is pointed towards the product. This shows that the reactants react and gives us product. Second, if the reactants or product are two or more, they are linked with plus sign between them, as in equation 2. CuSO4 and Zn are linked by plus sign, while the product ZnSO4 and Cu are also linked by plus sign, as there are two reactants and two products in the equation. So plus sign helps to link them. Third point, to make the chemical equation more informative, the physical state of the reactants are indicated in the equation. Their gaseous, liquid and solid states are indicated by writing the letter G, L and S respectively in the brackets. Moreover, if the product is gaseous, instead of G, it can be indicated by the arrow pointing upward. If the product formed is insoluble in water, solid, in the form of precipitate, then instead of S, it is indicated by the arrow pointing downward. And when reactants and product are in the form of solution in water, they are said to be present in aqueous solution state. This state is indicated by the putting letter AQ in bracket after the formula. Thus, equation 2 of before can be represented as CuSO4 in bracket AQ, that is, it is in aqueous state, plus Zn in bracket S, that is, it is in solid state, gives ZnSO4 in bracket AQ plus Cu in bracket S, as they are in aqueous and solid state respectively. Fourth point, when heat is to be given from outside to bring about a reaction, it is indicated by the sign triangle written above the arrow that indicates the direction of the reaction. For example, the reaction in which slaked lime is formed on heating limestone is written as follows: CaCO3 in bracket S on arrow triangle, that is, on heating gives CaO bracket S plus CO2 arrow pointing upward, that is, CO2 is in gaseous state. Similarly, the fact that heat is released during the reaction between the aqueous solution of copper sulfate and zinc dust is indicated as follows: CuSO4 in bracket AQ plus Zn in bracket S gives ZnSO4 in bracket AQ plus Cu in bracket S plus heat. Thus, when heat is required for performing the reaction, it is indicated by the triangle sign above the arrow, and when heat is released by the reaction, it is indicated in the end beside the product. Fifth, it is necessary to fulfill certain conditions like specific temperature, pressure, catalyst, etc. to bring about some reactions. These conditions are indicated below or above the arrow, indicating the direction of reaction. For example, the reaction of vegetable oil takes place at temperature of about 60 degrees Celsius with hydrogen gas in presence of nickel, which acts as the catalyst. It is written as vegetable oil in bracket L plus H2 in bracket G on the arrow above 60 degrees Celsius, below nickel catalyst, gives Vanaspati ghee in bracket S. This states that vegetable oil on heating with hydrogen gas at about 60 degrees Celsius in presence of nickel catalyst gives us Vanaspati ghee, which is in solid form. Thus, the conditions that are required for the reactants to carry out the reaction are written on the arrow, either above or below the arrow. Point 6. Special information or names of reactants or products are written below their formulae. For example, copper on reaction with concentrated nitric acid gives reddish colored poisonous nitrogen dioxide gas, as in Cu plus 4HNO3 gives CuNO3 twice plus 2NO2 plus 2H2O. Here below HNO3 in bracket concentrated is written. This indicates that during this reaction copper is reacted with concentrated nitric acid. However, on reaction with dilute nitric acid, the product produced or formed is nitric oxide gas, as in 3Cu plus 8HNO3 below in bracket dilute gives 3Cu NO3 twice plus 2NO plus 4H2O. This implies that the indication of the state of the reactant is very important, as the product obtained is different for different state of reactant. These were the few rules, but very important rules for writing any chemical reaction. Since we have now understood how to write a chemical reaction, let's study how to balance the chemical reaction or chemical equation. When the number of atoms of the elements in the reactant in the equation is same as the number of atoms of elements or of those same elements in the product, then the equation is called as the balanced equation. If the number of atoms of each element is not same, on two sides of the equation. It is called as an unbalanced equation. Let's understand this by considering the equation we studied before. The equation of CuSO4 plus Zn gives ZnSO4 plus Cu. On both the sides, the number of atoms of Cu is 1. The number of atoms of S, O, Z are same on both the sides, that is on the side of reactants as well as on the side of product. This was the example of balanced equation. Steps in balancing a chemical reaction. A chemical reaction or equation is balanced step by step. A trial and error method is used for this purpose. Consider the following example. Sodium hydroxide plus sulfuric acid gives sodium sulfate plus water. Step 1. Write the chemical equation from the given word equation, that is NaOH plus H2SO4 gives Na2SO4 plus H2O. Step 2. Check whether the equation is balanced or not by comparing the number of atoms of the various elements present on the two sides of the equation. Take a look at the table given towards the right. Number of atoms towards the reactants and number of atoms towards the product. Element Na 1, 2. Oxygen, that is O, 5, 5. Hydrogen H, 3, 2. And sulfur S, 1, 1. When we look at the table, it seems that two elements are already balanced, that is oxygen and sulfur. But the other two elements do not have same number of atoms on both sides. Thus the equation is not balanced. So now step 3. It is convenient to start balancing an equation from the compound which contains the maximum number of atoms. Moreover, it is convenient to first consider that the element in this compound which has unequal number of atoms on the two sides. That is, in equation above, there are two components, NaSO4 and H2SO4, which contain maximum number, that is 7 atoms each. Any one of them can be selected. Let's select compound Na2SO4. Further, select sodium for balancing, as the number of atoms of sodium in this compound is unequal on both the sides. It should be remembered that the formula of the compound cannot be changed while balancing the number of atoms. It means that here, to make the number of sodium atoms in the reactants as 2, the formula NaOH cannot be changed to Na2OH. Instead, the factor of 2 will be applied to NaOH. Write down the resulting equation on doing this. Thus the equation becomes 2NaOH plus H2SO4 gives Na2SO4 plus H2O. Now let's check whether this equation is balanced or not. Take a look at the table towards right. We find that the equation is not balanced as the number of oxygen and hydrogen atoms are unequal and on both the sides. First, balance the hydrogen number as it requires smaller factor. Apply the factor 2 to the product H2O for balancing the equation. Write down the resulting equation, which is as 2NaOH plus H2SO4 gives Na2SO4 plus 2H2O. Now let's check whether this reaction equation is balanced or not. Well, while taking a look, it is seen that the number of atoms of the elements are equal on both the sides. This means that the equation is balanced. Now, let's take step 4. Write down the final balanced equation again. That is 2NaOH plus H2SO4 gives Na2SO4 plus 2H2. In this way, a balanced equation is obtained from an unbalanced equation by applying proper factors to appropriate reactant or product so as to balance the number of each element in steps. Thus, by following the steps from 1 to 4, we can obtain a balanced equation from the unbalanced equation easily. So remember these steps carefully. Now, let's study the types of chemical reaction. In accordance with the nature and the number of reactants and products, chemical reactions are classified into following 4 types. That is combination reaction, decomposition reaction, displacement reaction and double displacement reaction. Combination reaction is the reaction in which 2 or more than 2 reactants combine to form a single product. That is, when only one product is obtained after the reaction of various products, it is called as combination reaction. It is similar to addition. Like when we add various numbers, we get answer which is only one number, can be called as product. Decomposition reaction. When a single reactant reacts to give 2 or more products, it is called as decomposition reaction. It's like the breaking of the reactant. A single reactant is broken into several parts. That is several number of products. Displacement reaction. It is the reaction in which the place of the ion of less reactive element in the compound is taken by another more reactive element by formation of its own ions. In this reaction, the reactants react and the stronger ion replaces the weaker and forms the product. Double displacement reaction. The reaction in which the ions in the reactants are exchanged to form a precipitate is called as double displacement reaction. In this reaction, reactants react and they exchange their places with each other and forms the product. Now let's understand this by considering the example. Combination reaction. Take a look at equation 12. Ammonia reacts with hydrogen chloride and forms ammonium chloride. Here NH3 reacts with HCl and together form NH4Cl. Thus two reactants react to form the single product. Similarly, when magnesium is burned in air, it forms white powder magnesium oxide, that is 2Mg plus O2 gives 2MgO. Two reactants, magnesium and oxide, together forms the single product magnesium oxide. These two are the example of combination reaction, which shows that the combination of two reactants gives the single product. Second, decomposition reaction. On heating, the sugar is divided into two substances, that is carbon and water, represented as C12H22O11 on heating gives 12C plus 11H2. This is the reaction in which there is only one reactant, which gives rise to two or more products. Is called decomposition reaction. Displacement reaction. In the beginning of chapter, we studied that on adding zinc dust to colored copper sulfate solution, a colorless solution of zinc sulfate is formed and heat is generated. From that, we learned that Zn2 plus ions formed from Zn atom takes the place of Cu2 plus ions in copper sulfate. The Cu atom formed from Cu2 plus ion comes out. It means that Zn displaces Cu from CuSO4. This is the example of displacement reaction. Double displacement reaction. We know that white precipitate of silver chloride is formed by an exchange of silver and sodium ions present in the reactor. The silver and sodium exchange their places and forms the product. This is the example of double displacement reaction. Take a look at equation number 9 to understand this reaction. Here are few practice questions given. Write the answers in your notebook. Do answer the questions in between the textbook. If you have any doubt regarding this chapter, do ask in the comment section below. Do subscribe my channel and click the bell icon for notification. Do like and share the video. Thank you.